Hi, Saitech students. In this session, I will be discussing about the prism. So, first of all, you should be able to draw the prism neatly, and you should be able to identify the label. And as far as ray diagrams and other diagrams under optics, let it be ray optics or wave optics, the arrow marks have very significant role. Okay, now let us try to draw the prism diagram and what are the important parameters associated with this prism. Okay, right. So this is the prism, and A is the angle of prism. A, B, C, that represents the prism. BC is the base of the prism. AB is the incident surface, or you will follow, this is the incident surface or incident face of the prism, and AC is the refracted plane or refracted side. Okay, right, or it can also be called emergent surface. So this is the incident surface. AB is the incident surface. Let us draw first of all a normal to the incident surface AB. So this is normal. You can put N dash. Okay, that represents normal, and it should be usually perpendicular to the refracting surface. Okay, it should be perpendicular to the refracting surface. Now let us draw an incident ray obliquely. Okay, so this is the incident ray. Let me fix a point P and Q here. Okay, so P and Q. So this is the incident angle. So the angle subtended by the, you have to put the arrow mark properly. So the angle subtended by the incident ray to the normal is called incident angle I. Okay, you know very well, that is, this is the rarer medium. Okay, and inside which you have got glass, so it is the denser medium. So this is denser, and outside rarer, again here rarer. Rarer means here here and here it is glass being denser. Do you understand? Okay. Now the light travels from a rarer medium to denser medium, so it bends towards the normal like this and put the arrow mark. Okay, and that is the refraction. So you can put the angle subtended by the refracted ray to the normal as R. You can put R. Do you understand? Okay, so you can put R1 also. Okay, so this is R1, first refracted angle, and then here again it gets refracted. Now draw a normal here. Okay, draw a normal. Do you understand? And when you draw the normal, now the light travels from denser to rarer. It means, and this is the N dash, that is normal. So the light should get deviated from, that is away from the normal. So it should travel like this, and this is called what? The emergent ray. So this is known as, so if it is a PQ, you can put this as RS also. Okay, or yes. Do you understand? So this RS is called the emergent ray. And what is the incident ray? PQ is the incident ray, RS is the emergent ray. And this angle of emergence can be represented as E. So it is the angle subtended by the emergent ray to the normal. So you can put E here. Right? And what about this one? And this is taken as the refracted ray, refracted angle of refraction 2. That is, you can put R2. Because this is the second refraction, this is the first one. Okay, so here the refraction takes place from rarer to denser. and the second refraction takes place from denser to rarer. But by our convention, we take always rarer to denser. Do you understand? Right. So this is taken as R2. You may argue that, sir, this is traveling from this medium to another medium. So it should be the incident ray, but it is not incident. So we always by convention take that is starting light should be from rarer medium only. So in that case, this is the incident and this is the refraction. To avoid the confusion, you can also put I2 here, but instead of I2, most of the authors they say it is emergent. So you can put emergent, which is nothing but I2 only. Some authors they put I2 and this one is I1, and inside which we have R1 and R2. So let there be no confusion at all. I hope now everything is clear, right? And you should find out one important point. R1 is equal to R2. Please make note of it. R1 is equal to R2. When that is I is equal to E for that is at minimum deviation. Take this point. At minimum deviation. Minimum deviation. It is said R1 is equal to R2. Are you able to follow this? Right. And what is the angle of prism? Here you have the angle of prism, and that is angle A. That is called angle of prism. Okay. Now we have the formula. Let us take down the 19th formula. That is I is equal to, that is angle of incidence plus angle of emergence is equal to angle of what? Prism plus angle of minimum deviation. So you may be interested to find out, the not minimum deviation, angle of deviation. So what is this angle of deviation? Let me explain. Now we have the deviated, that is the part deviated refracted ray, and assuming that if it goes like this, straight, undeviated, so put the straight line. And similarly for the emergent ray, you can put the straight line here. Okay. Now you can find the angle between these two undeflected path can be called deviation, angle of deviation. So what is angle of deviation? Angle of deviation is the angle subtended between, that is undeviated incident ray and undeviated emergent ray. Are you able to understand this point? So this is very important. So this is called delta. So what is undeviated incident ray? The PQ is extended. It is produced like this. And similarly, emergent ray is produced like this. So the angle between these two can be called, that is angle of deviation. Do you understand? Right. And so I plus E is equal to A plus delta. What is delta? That is angle of deviation. Okay. Right. Take down. And let us proceed with the next formula. That is, this is for prism, 20th formula. That I have already explained. That is I is equal to E and R1 is equal to R2 when at minimum deviation for a prism. So at minimum deviation for a prism, I is equal to E, that is angle of incidence is equal to angle of emergence. Similarly, the first refraction angle is equal to the second refraction angle. Okay. Now 21st formula. Here we are interested to find out the refractive index of the second medium with respect to the first one. So that should be represented as mu21. Okay. That is nothing but mu2 divided by mu1. Okay. So that is equal to what is mu2? That is the second one, is it not? So that is nothing but sine of A plus and angle of minimum deviation A delta m, okay, whole divided by 2. So this is the appropriate formula for mu2, and for mu1 it is nothing but half of sine of half of angle of A, angle A. It means that is sine A by 2. Okay, sine A by 2. Are you able to follow this? And what is this dm, delta m or dm it can be? So delta m is nothing but that is angle of minimum deviation. Okay, right. Then now let us talk about the dispersion. So this is the formula for dispersive power. Delta is equal to delta V, that is angle of deviation for violet ray, minus angle of deviation for red ray. Okay, this is called the angular dispersion. So dispersive power is omega. Omega is given by, that is the angular dispersion divided by, that is mean value. Mean value here is y, that is yellow. So it can be delta V minus delta R divided by delta y. Y means yellow ray. So that is equal to, in terms of refractive index, mu V. Mu V means refractive index of the violet ray minus refractive index of the red ray divided by mu yellow minus 1, mu y minus 1. Are able to follow? So these are all the very important formula. They are used in solving problems related to prism. Okay, please make a note of it.